Welcome you all for today's class. Today we are going to discuss about psychrometric properties. How to find out psychrometric properties, because we know that for maintaining cooling in a space or in buildings, whether it is occupied by human beings or in some industries where some process or in research lab some process is going on. So we have to maintain condition inside the room, and we have to maintain properties. For that purpose, we require different properties of air. These properties are known as psychrometric properties. And psychrometric properties we can find out by watching by psychrometric chart. So psychrometric chart is a heart of the air conditioning. If you know how to interpret values from psychometric chart, then half of the problem of air conditioning is over. Next thing, rest of things are only using formula and applying mathematics to calculate heating and cooling load calculation, various factors, bypass factors, sensible heat factors. So many factors are there here. To make you understand, to learn how to find out these values, we have given a problem. And problem is that for given value of air, for given condition of air, enthalpy is given 55 kg per kilojoule, 65 kilojoule per kg, and relative humidity is given 60%. All these values already I have defined, I have discussed in video lectures. So here we are going to find out how to interpret these values which are asked in question. What is the absolute humidity omega? What is the specific volume V? What is the dry bulb temperature? And what is the wet bulb temperature from a given value and dew point temperature? Here we will construct a psychrometric chart. So values may differ, but process is same. By watching this lecture, you will be able to find out, you will be able to determine how to find out different values if two values are given in psychrometric chart. So let us draw first psychrometric chart and then finding out these values. So now starting drawing of the psychrometric chart, take a line. So this is a block diagram of the psychrometric chart, and we will use different colors for defining different lines. So these lines, this vertical line is for the absolute humidity. So now we will express absolute humidity. That will be 0.02, 0.04, 0.0. I think these values should be in grams. Kg. We have to define these values. So 0.002, 0.004, 0.006, 0.008. These values starting from here 0.000 something we can take 0.001, 0.0, this one will be equal to 1, 0.012, 0.014, 0.016, 0.018, 0.020. kg of water vapor per kg of dry air. This value absolute humidity omega is kg of water vapor, kg of water vapor per kg of dry air. So these values are arbitrary. These are not exactly according to psychometric chart, but to make you understand how to interpret, how to see these values on chart, that's why I am drawing this chart. So that in vertical axis I have taken absolute humidity 0.002 kg per kg of dry air. Means it will be around 2 gram, 4 gram, 6 gram, 8 gram, 10 gram, 12 gram, 14 gram, 15 gram, 18 gram, and 20 gram of the water vapor per kg of dry air. This is a chart, vertical axis, and then we will also draw different lines. Dry bulb temperature. Dry bulb temperature is the temperature of air at given condition. So, and we will also draw wet bulb temperature, specific volume, and the relative humidity, and then enthalpy. And from these lines, then we find out different values omega, specific volume, dry bulb temperature, wet bulb temperature, and dew point temperature. So first we draw vertical lines. These are dry bulb temperature. So let us take another color for drawing. We are taking yellow color for finding out dry bulb temperature. So take straight lines. Taking straight line here. These are vertical lines denoting dry bulb temperature. Dry bulb temperature. DVD. 5. Sorry. Then draw. Now we draw wet bulb temperature lines. They are almost 45 degree inclined. So the red lines are wet bulb temperature lines. I will denote later. Now next one is a specific volume line. I will show these lines with the dotted lines and taking another color. So these are almost, so we will take, these dotted lines are specific volume lines. These are specific volume, these are almost 60 degree inclined and parallel lines. These are 60 degree inclined parallel lines. So these are specific volume lines and values arbitrarily I will put here. These lines you can see dotted lines by blue are specific volume lines. These are specific volume lines. Next I will draw a humidity line, absolute humidity line. So choose another lines. That is a full line. I will choose next color. This one I will choose white lines. Okay, again not coming. These white lines and straight lines are absolute humidity or specific humidity lines. These are specific humidity lines. Specific humidity lines. These are parallel and straight lines. You can see on the chart parallel and straight lines. So one more line remaining, that is relative humidity lines, which shows what is a percentage of the water vapor present at given condition. So next line I will choose another color. So green line I will choose, absolutely green lines. These green lines are relative humidity lines. You can see these are relative humidity lines, relative humidity lines. So starting from here, 10%, 5, 10%, 20%, 30%, 40%, 50%, 50%. So one more line we can draw, 70%, 80%, 90% and 100%. Here 5 equal to 100%. You can see this line. This line is a fully saturation line, saturated vapor, pH diagram. So this line represents saturation line. Here phi equal to 100% means fully saturated. 100% means maximum moisture content reaches up to this line. So almost all lines we have drawn, and one thing more remaining is a enthalpy line. Enthalpy line we have to draw. So let us draw enthalpy lines. Take diagram here. This one, taking a straight line here. We will draw enthalpy line. Taking a straight line here and a straight line here, and joined by another line. That is another color. We use this color, red color. No, it is not a straight line. This one is a enthalpy line. So we have to mark enthalpies by different grades. Choosing another color for grading this line. 10, 20, 30, 40, 50, 50, 70, 80. So kilojoule per kg. Value is kilojoule per kg. And we can mark smaller points also. They are between these two values, so that you can easily get required values. In actual diagram, you will find more fine divisions. But according to our problem, you know that the enthalpy lines, so the enthalpy lines are always parallel to wet bulb temperature lines. So these lines are parallel to wet bulb temperature lines. According to given problem, we have given in problem H equal to 65 kilojoule per kg and phi equal to 60%. So we have to find out phi. Phi already denoted, and let us define the wet bulb temperature and dry bulb temperature also. So here let us define wet bulb temperature and dry bulb temperature by using white color. So this one is 10 degree, 20 degree, 30 degree, 40, 50, 60, 70 and 80. Dry bulb temperature DBT. Dry bulb temperature we have taken actual value. You already I told you actual values are different, but we have taken arbitrary values because actually drying is very difficult. So just to make you understand how to find out values from given values. So here dry bulb temperature we have taken 10 all values in degree centigrade, and these are wet bulb temperature 15, 20, 25, 30 and 40. 40. These are also degree centigrade. So these lines are wet bulb temperature lines, and these are specific volume lines. So let us define a specific volume line by another color. I will choose blue color. So 0.0 so we choose yellow color. 0.78, 0.82, 0.84, 0.86, 0.88, 0.9, 0.92. These are specific volume line. These are meter cube per kg. स्पेसिफिक वॉल्यूम मीन्स क्या होता है? मीटर क्यूब पर केजी. स्पेसिफिक वॉल्यूम ऑलवेज डिनोटेड मीटर क्यूब पर केजी. दिस इज वैल्यू स्पेसिफिक वॉल्यूम मीटर क्यूब per kg. So these are given. Now it is complete in almost according to your requirement. This graph is complete. Now find out from the given data h equal to 65. So here see on enthalpy line h equal to 65 line. This line is h equal to 55. So draw parallel line with 65 kilojoule per kg parallel to wet bulb temperature line. So draw, and next point, intersection point is 50%. So you know that 50% line is here. 5, 10%, 20%, 30%, 40%, 50%, 60%. This line is a 50% line. So from 50, so let us take a straight line so that we can draw straight line. We can take and take another color. This color I am choosing for drawing straight line. So 65, from 65, this line is not, let us see, let us take white color. From 65 we draw a parallel line. This is a parallel line, and the parallel line to parallel to wet bulb temperature line. Up to 60%, you draw here up to 60% of the phi. Parallel to, you see parallel to wet bulb. Parallel to, now cutting at this point. You see this point, you know. Now let us define this point where we cut here. So this is a point, this is a required point. According to this point, we have to find out all values. So this one is a 60% relative humidity and 65 is enthalpy, and we got intersection point. So this point is A. This is the point A, and on the basis of that point you can find out all values. So first you get omega. So again draw parallel line from here. Draw parallel line up to omega. We take dot dot line, and we are defining. We will take red color. So you see here. From here you drop, you come here to this point. Here you have to find out omega, absolute humidity. You see that this point is lying between 0.012 and 0.014. So more than half value. So by if you have more divisions here, you can easily find. Suppose this point is around 1 point omega. You will find here omega equal to, first we make all intersection lines, and for dry bulb temperature you go vertically downward you come down. For dry bulb temperature, this is the point where you can find out dry bulb temperature, and this line, and you draw this is a line where you have to find out wet bulb temperature, and you have to find out DPT, dew point temperature. For dew point temperature you have to go down side, and where it touch full saturation line, drop again vertical line. So this one is a dew point temperature. This one is a dew point temperature. This one is a dew point temperature where I mark a cross. So see all values, and specific volume line. You have to find out from where is to where this point is lying between two specific lines. 0.86 and 0.9. So by using interpolation between these 2 points, you can easily find out all these values. Main thing is that you have to find this point, and with respect to this point, you can find out all values. Suppose we have calculated here omega. From this graph you can see omega equal to, you see here omega. At this point you see omega is around 0.0135 kg of water vapor per kg of dry air. And next one is a specific volume V. So see here where this point is lying between two specific lines. One specific line is 0.86, another one is 0.9. So between these two lines, 0.8 and 0.9, so 0.002. So it is more than 0.0.86 and less than. So this value will be around 0.0875 meter cube per kg. In actual diagram, you will find more lines, because here I could not draw more lines because it will become more complex and you will not be able to see this one. That's why I am by using our ability to interpret between two lines, getting values near most, because in that kind of problem 5 to 10% error is acceptable. No one can find out exact values. No two-person can find same values. So some 5 to 10% error is possible, because you are finding these values by watching, by interpreting these graphs. So V equal to 8. Next one is 0.0875 meter cube per kg, and next one is dry bulb temperature. Already you have to see dry bulb temperature on this line. So between 50 and 50, and more near to 50. So it will be around 57 degrees centigrade. Deep it will be equal to 57 degrees centigrade. 57 degrees centigrade. And wet bulb, see this line is closer to 30 degrees centigrade and away from the 25. So between 25 and 30, and it will be around 28. You see here, if we draw line between these and you mark line with 10 points, 10 divisions, you will see it is around 28 degrees centigrade. It will be around 28 degrees centigrade. So this one is a 28 degrees centigrade. Dry bulb, we have found out dry bulb 57 degrees centigrade. It was not a dew, this is a dew point. This one is a dew point. So how do you find dew point? Already draw parallel line, we have drawn parallel line and then coming down. So it is between 30 and 40. So it is closer to 30 and not in the midpoint. So it is around 33 degrees centigrade. Dew point is 33 degrees centigrade. 33 degrees centigrade. So all values we have calculated by watching this, by interpreting this psychometric chart. So this psychometric chart is a core and heart of the air conditioning process. If you are expert in interpreting values, one thing is clear, that if two different values are given, any two values, out of all values, if any two different values are given, you can get an intersection point, and from that intersection point you get every values, and these values are used in calculation of the cooling and heating load of the air conditioning process. That's why this chart is very important, and I think you will not have any doubt regarding how to see this chart. And if you make practice to finding out different processes, for finding out different processes, you need psychometric parameters from psychometric chart, and then you can calculate values. Then you can find out heating load, sensible heat load, sensible latent load, total load, sensible heat factor. All these calculation you can do here. So next topic I will discuss mixing process. Mixing of the air in air conditioning process, and also we will discuss sensible heat factor by defining sensible heat load and latent heat load. So in next lecture, we will discuss all these things. Thank you very much. And please make a comment how you feel about this lecture and what you really want to make a modification. So your comment and your suggestions are highly appreciated. Thank you very much.